Hello everybody. So today's lecture we're going to start is on modeling, like entity relationship modeling to be specific. So we'll see what this means. So why learn about database modeling? So that's the first question, right? So like I said in the introduction, the way in the introductory class, that is, so the way in which data is stored is important for us for its subsequent access and manipulation through some kind of language. For us, that is SQL, that is sequential query language. Why? Because we want the database to be easy to write and correct and make any changes, understand queries. So all these things have to be easier. Um, Minor changes like schema change. So schema is basically something that describes a database. So, and we'll see the details of that in the coming lectures, but for now, schema is something that describes the database. So any kind of minor change in the problem domain should not cause that whole schema to change. So that's one of the objectives. Then the other is any kind of major changes in the problem domain should be handled without too much difficulty. Okay, and that's what like a good database model provides us with, that it provides these facilities that these things become easier. And then the model should be able to support efficient database access, because efficiency, as you know, is important in database access. Again, going back to the example of Google, if you have to wait on Google's database for milliseconds, microseconds, 2 seconds, 5 seconds, you say, oh, it's too much, right? So that's why efficiency is foremost. Objectives of today's class, like these are the things. We'll define some terms, understand the basic topics, models, uh, understand different types of relationships, uh, try to learn how to draw those ERs, and then some kind of conversion for those entities. So the first and foremost, the ER model. Like, what is the purpose of an ER model? Like I said, it allows us to design our database, right? So the basic purpose is for us to be able to sketch a design of a database. It says informally on the slide, but it's a good ER model is in fact, I wouldn't say needed, but every organization has that. Okay, because it allows us to represent different types of data and how they relate to each other. So anybody in the organization, if he's here today, gone tomorrow, anybody coming in new, they can look at that document, look at that ER model and understand what the database is doing, okay, or what's happening in the database. So these sketches or pictures that describe the overall database are known as ER diagrams or entity relationship diagram. And the power of these diagrams is that it's easier to take this ER diagram design and convert it into a relational database system like MySQL. So it starts from an idea like what the database is supposed to do, then you design it, then we say convert that design into a relational schema. And again, schema is something that describes your database, and then put all that in a relational database management system. Okay. So the first and foremost, database design. So the methodology again we're using is the ER diagram. Then ERs are converted to a data definition language, the DDL, which describes how your database should be, and so on. So the ER model has two basic constructs, the entities and the relationships between those entities. Okay. So anything in the ER model, so E stands for entities, R for relationships among those entities. And we'll see what these terms mean. So entity, first and foremost, is something that can be or that has significance in the system, in the database, that is. For instance, an entity instance could be a person, a place, an object, an event, a concept, like anything that you want to store information about in a database. So entity is something that allows you to store information in a database. Okay, the collection of those instances become a entity type. And in databases, when you think of databases, you think of different types of tables. So a table can store information about an entity type. For instance, student is an entity type, right? So all of you students in the class are entity instances. So we have a John, we have a Smith, we have a David. So John, Smith, and David are three instances of the entity type that is a student. Okay, so when we say something like we need to store the information about students, right? So then we make a student table, and each of those rows of that table, right? So that's what this says, that it corresponds to a row in a table. So each of the rows stores information. One row stores information about David, the other about Peter, the third about Smith, and so on. So entity type is a student. However, when we say entity, we usually refer to as an entity type. We do not normally talk about entity instances in the ER model. So in the ER model, we don't say E stands for an entity type and R for relationship. We just say that E stands for an entity. Okay, so entity, entity type mean the same thing. Then the relationship. So relationship, like the slide states, links entities, or is a link between different entities. For instance, you are a student, you live in a dorm, right? So dormitory can be another table. So student lives in dormitory, or student goes to gym. So goes to or lives in is a relationship between these two different entity types or entities. Okay. And once we see like these things graphically, it'll make more sense. And then attribute is something, a property or a characteristic of either of these, an entity or a relationship. For instance, student has many attributes. You have like height, color, medical condition, area you're from, and so on. So all these things can be stored about a student in a database, right? So these become the attributes of a student. Similarly, relationships can have attributes. For instance, when we say student goes to gym, then we say student goes to gym very often, or goes to gym 3 times a semester, 5 times. So this going has its own attribute, like how many times, and so on. Again, things will become clear in the coming slides. So entity type, again, talking about the same thing. Set of attributes. So you are a student or a person, you have an ID, name, address, hobbies, different things collected together, or attributes of an entity type. Then domain are the possible values of an attribute. For instance, name is alphanumeric, so the domain is alphanumeric. For instance, 50 cent, so it can be numeric as well. IDs are numeric usually. Address is again alphanumeric. So they are values that can, like the domain, like in mathematics, the domain of these values is of any attribute, that is. Then there is something called a key. the minimum set of attributes that can uniquely identify an entity. Okay, minimum set of entities, minimum set of attributes, meaning your name and your ID together can define a person as well. But what's minimum is only an ID. If I say student number 5, student number 6, so only the attribute, or your social security number, for instance, is the minimum thing that can identify you, right? So that thing becomes a key in the table. Then entity schema is like the schema, the word schema, whenever it comes, you should know that it is something that defines something, not the instances, but the overall architecture of something. So the entity types name, the attributes, the different types of constraints that are there, those things are called the entity schema. Okay. Then entity, basically same thing going over. So you slide for your reviews. So how do we represent entities? So in ER diagrams, an entity is represented by a rectangle. Okay, and any type of attributes that this entity has, like your person name, address, so on, so those are represented inside that rectangle. For instance, something like this. So in here, these big rectangles, these are the entities. So we have a customer entity, an order, product, item, so on. Okay, but we haven't listed any of the attributes inside these rectangles, which we can and which we will. I think it's, yeah, for instance, in this next slide. So we have an entity name and you have different types of attributes listed inside the rectangle. Okay, so this is fine as well. But sometimes, like in different types of softwares, etc., you'll see entity listed as this. You click on this and it will open up those attributes. Okay, and then the lines between these entities, these are the relationships. Okay, so an entity type is a rectangle. Any line going out from an entity is that relationship. Relationships have cardinalities and so on, which we'll see in the coming slides, and what these symbols mean. So there are different types of entities, as you can see here. So either it's like a 90-degree angle, box, rectangle, or there are like curved edge box, or there's a box that has two lines. So these are different types of entities. One is called a strong entity, the weak entity, or the associative entity. And we'll learn about these shortly. And again, relationships can be binary, they can be three-way, tertiary, ternary, or a unary relationship in which the entity is related to itself. Okay. Then mandatory one, when the relationship is mandatory and it's only one, it's represented by a double line. If it's many, it's represented by these three lines called a crow's foot. Optional with a small o and one for one. Like one line is a one, and optional is an o. Mandatory represented by a second line, and depending on if it's one, there's a one, and if it's many, it's a crow's foot. Okay, and we'll see these shortly as well. So how do you like when you're modeling or you're thinking about modeling a database, what should become a box, like what should become an entity? So entity should be, when you're thinking about designing a database, an entity should be an object that can have many instances, an object that can be composed of many attributes, anything that you're trying to model, minimum criteria is that it should have multiple attributes. If something has only a single attribute, maybe it's better represented as a relationship. Okay, usually more than one attribute of something that you need to model in the real world uh, can be an entity. It should not be a user, it should not be an output, it should not be an instance. So for instance, you cannot say I am going to store information about John because John has height, John has weight, John has eye color, hair length. So there are different attributes. So I'm going to store information about John. Yes, if you need to store information about John, make it a student entity, not John as a rectangle, right? Because John is an instance of a student or a person. Okay. So instances should not be made entities, only entities or entity types should be made as rectangles or boxes in the ER diagram. So for instance, in this slide, it shows that something is a system output. For instance, the expense report, um the user of the system who's a treasurer. So instead of modeling all these things, we only model that expense is charged to an account, or an account charges multiple expenses, right? So this bottom figure as compared to this top one, you can see like where the difference lies, right? Um, so instead of modeling those outputs or users, instead of making these four boxes, just made two, and that should capture anything that we want to do in this figure. Again, attributes, like I said earlier, are characteristics of an entity. Um there are different types of attributes. Some are required, some are simple, some are single valued, derived attributes, and so on. And these are just like features, fairly self-explanatory. Composite attribute, for instance, is an address. An address is a composite attribute. Why? Because an address has house number, street address, city, state. So those are different um, individual attributes that combined together form something as a composite attribute, which is your address. Okay. Uh, then keys, like I said earlier, anything that uniquely identifies an individual instance is known as a key. Keys can be simple, keys can be composite as well. So a combination of your first name, your last name, and the date of birth, that can be a key. If let's say social security is not available, or the combination of your eye color, your hair length, something like any attributes combined together, if they identify, they become a composite key. Okay. Then candidate keys are keys that satisfy the requirements of being identifiers, but they're not chosen as yet for the key, right? So they are candidates to become a key. Once you choose an attribute as the identifier, that becomes the key itself. Okay. So candidates are keys that can be chosen, and key is any key that you choose to identify um, an entity. And criteria for these identifiers or keys are things usually chosen that will not change in value. For instance, your social security number stays from the time you're born till you're dead, usually, right? For most individuals, unless there are like specific circumstances. But other than that, your social security number will not change in value for your whole life. That is why that is the best identifier for an individual in the US, right? And anything that cannot be described as a null value. For instance, you cannot say this person um, a US citizen does not have a social security number. You cannot say that, right? So every US citizen has to have a social security number first. Why? Because that is the identifier. So that identifier cannot be null. Okay. And usually, like if you have a composite or a long key, it's better, or databases or like database people prefer to have new or simple keys. So now in these most database engines, MySQL, Oracle, and so on, you can auto-generate numbers or identifiers, right? So those auto identifiers are provided by the database, so you don't have to choose like 5, 6 attributes to define an individual record in the database. So like I gave you the example of the address, so that is a composite attribute written like this in the ER. So composite attribute on the top, then in parentheses uh, the different component attributes or simple attributes. Okay. Then there is something called a multi-valued attribute, which is represented in the ER in curly braces or in square brackets. You can identify something called a derived attribute. So derived ones are derived from the data that's available. For instance, years employed, if the employee was, so based on date employed, you can derive this attribute, right? Skill, it's a multi-valued, meaning that you can have multiple skills. You can ride, you can run, you can swim, you can whatever. So an employee can have multiple skills, right? So that's why this value or this attribute can hold multiple values. Name, address, etc. mostly they're unique. Addresses again can be multi-valued, but it depends on the design of the database, how it's designed in the database. In this figure or in this ER, we are saying an employee has an employee ID, he has a name, he has an address, which name and address are composite, hence these parentheses. He has a date employed, which is a simple attribute. Skill is multi-valued attribute. It can hold multiple values. And or years employed is a derived attribute, and it can be derived from, let's say, date employed. So the identifiers, whenever you have a key, you underline that or write in a boldface. I prefer or I recommend underlining definitely and boldface if you have the facility. Meaning if you're doing it on paper with hand, definitely underline, boldface and underline if you're doing in a word processor or like Microsoft Visio or those kind of tools. Okay. Um, so you have to underline the key for sure. If you have composite attribute, then underline the composite identifier, or you can underline all these three. Okay, but definitely do underline the composite one. Then relationships. Next thing is relationships. So relationships, like I said earlier, relate two or more entities. For instance, the instance, student instance, John majors in computer science. So the entity is student, the other entity is course. So the instance or the relationship between these two entities is majors in, right? So student entity type related to department entity type by this relationship, that is majors in. It's represented textually with lines of each of the entities that are involved. Okay. An attribute, like I said earlier, describes the individual, either the entity or the relationship. And for relationship, for instance, the example says since 2000. So since 2000 is an attribute of this measures in a relationship. And we'll see graphically, then it'll become clear. So for instance, if you read this top figure now, forget this bottom B part, only look at this A type on the top. So what are we saying? We are saying employee completes a course, right? So when we have these crow feet at both ends, it can read as many employees can complete many courses, okay? And each of them have their attributes. Courses have their own attributes, employee have their own attributes, okay? And these are just examples of what things can be stored in this employee and what things can be stored in courses. So employees can be Chen, Richie, and so on. And courses can be C++, Java, SQL, so on. Okay. So instance. So these are different instances. Usually these are not modeled in ERs. ERs are only modeling the relationship type that employee completes a course. That's it. So these things are modeled. These are not modeled at all. You don't list every instance of the employee in the figure. Why? Because then what's the purpose of the database, right? So the figure should only give a overall like a high level view of the database. So we do not model instances. Relationships can have their own attributes, like we saw, and we'll see like further down the class. Two entities can have more than one type of relationship. Okay. And what is an associative entity for now? These two, like put them on the back burner. We'll come back to these two because they'll become clear with the figures. So then relationships have degrees, or like how many entities participate in those. Okay, if only one entity is participating in the relationship, it's a unary relationship. If two entities or a relationship is between two entities, it's binary. If a relationship is between three entities, it's a ternary relationship. So for instance, a unary relationship with this entity, you define something like this. Binary is between two, three-way or ternary is between these three entities. Then the next or like one of the most important things is the cardinality of relationships. So one-to-one is the first one, that each entity in the relationship can have exactly one related entity. One-to-many, that one side of the entity can hold one value and on the other side it can have multiples. For instance, when we say person or like parent has children. So parent is an entity, children is an entity, each of them can have multiple records in them, and have or father or mother, whatever the relationship between them, can be one to many. So one father can have multiple children. So that is a one to many relationship. And then many to many is athletes on a team. So there are many athletes on on multiple teams, right? So you could be in rowing, you could be in judo, you could be in swimming, and Smith, David, Peter, all of them can be in all of these teams, right? So you have many students in many teams, for instance. And again, figures will show these things more clear. And then there are constraints on these cardinalities. For instance, you must have a parent. So you have to have, like, there's a must, or it's optional, or there is minimum, you need at least one, you can have many, and so on. Okay, and we'll see things in, again, figures. So example of these things, these relationships and their cardinalities. So unary relationships are, so there are three unary relationships here with different types of cardinalities. Again, unary relationship with different cardinalities. So let's look at the first one. So what does this figure read as? A person is married to another person, right? So since it is one-to-one, the lines are like there is no crow's feet on this, because if you remember, crow's feet represents a many side. So this one says person is married to person. Now if you think of instances, you can say David is married to Nancy. Peter is married to Samantha, and so on, right? Uh, so there is only one at one end, unless let's say you're in mm, like Utah or somewhere. So then you can model it as something else, like a person is married to multiple people. But then that modeling is different in this figure, or what it describes. It is described as now. You can read it only as a person is married to another person. What does this figure now say? So it's a one to many. So one side is one, many side is a crow's feet. So what does it say? One employee manages multiple employees. One employee manages multiple employees. It can be manager of a McDonald's, for instance, manager of something, president of a university, manages multiple employees. Okay, so multiple or many or more than one is represented as a crow's foot. Again, one-to-one example, one team stands after the other on the podium, let's say. So only one team stands after the other team. If you want to model that one team's or multiple teams stand after one team, so you can make this side as the crow's foot. Okay, then it'll say multiple teams stand after one team. Binary, two entities are involved with different cardinalities. Let's look at those. So what does this figure now read? One employee is assigned to one parking space, one to one. Product line contains multiple products. So one product contains, or one product line contains multiple or many products. And then if you want to say many to many, many students register for many courses, right? So John, Peter, Smith, David register for 326, 501, 526, so on. Okay. Then a three-way relationship is something like this. Many vendors supply many parts through or coming from many warehouses, or many vendors supply many parts to many warehouses. Okay, whichever way you want to model. So vendor X can supply part C to warehouse Y, or vendor Y can supply part A to warehouse M, or so on. Okay, and this is that attribute of a relationship. So they're represented as a dashed line And then so this supply relationship between these three entities can have its own attributes. So vendor is supplying a part to a warehouse with this shipping mode, whether it's air, uh, sea, road, at this cost. Okay, so this supply relationship can have its own attributes listed like this. Then examples of those cardinality constraints. So cardinalities, if you remember, are these. If it's mandatory, there's a dashed line or there's a dash. And if it's one, there's a one. One has a one or a dash, and optional is an O. Many is a crow's foot. So when it's mandatory, there's a dash and there is many. Mandatory one is dash and another dash. Okay, so let's read this thing. What does it say? So we are saying one patient must have a recorded patient history. Okay, one person or one patient uh, must have a recorded patient history. And reading the other way, multiple patients must have a recorded patient entity or patient attributes. Okay. So reading this way, a patient must have recorded um, patient history, and when we come to read this, so the patient history is mandatory and there can be many of those, meaning one or more. So a patient must have a patient history and it's one or more. Reading this way, a patient history must be recorded for one patient. So in the same history, you cannot have multiple patients, right? So reading this way, a patient history must be recorded for one patient. And reading left to right, patient has recorded or must have a recorded patient history, and he can have multiple of those. Optional. So optional is an O. So reading left to right, an employee is assigned to multiple projects. And this assignment is optional, meaning that he may be assigned, he may not be assigned to one project. Reading the next or right to left is project must be assigned to one or more employees. Okay, so you can see how you draw these. The side that you're reading to, that's where this you place these signs. So again, reading from right to left, if we're reading from right to left, we don't read these symbols that are next to project. We only read the ending side. So which is a single dashed line and a crow's foot. So let's read that a project must be assigned to one or more employees. So one or more is a crow's foot. And again, optionals are O. So what does this thing read now? So if you remember, person is married to, so now we're putting these constraints on those relationships. So reading both ways. So let's read this way. So going in, we'll have to read this. So we're saying a person is married to one and only one, which is this dash, but the marriage is optional, meaning that a person does not have to be married to that person, any person, right? So if you're a single, then is married is optional. Or another way to say is a person is married to at most one other person. And when you put that O, it says the person may not be married, right? That relationship is an optional relationship. Okay, and this is like those instances. Again, we don't model those. These are just listed for your understanding that Kelly is married to Mac, Shirley is married to Alice, and so on. And then if you remember, we said that an entity can have, like two entities can be associated with each other in multiple relationships or through multiple relationships. So employees work in departments, right? So an employee works in department, or an employee manages a department, right? So now you have two relationships. The top one is works in, the other bottom one is manages. And if you read it the other way, department has workers or is managed by the way, we don't list them as two separate ones. We only list works. You can just say works here and manages down here. So you can read it both way. Employee works in department, department has workers which are employees. Okay. Uh, so there are two types of relationships between an employee and a department. So two entities can have multiple relationships. But for us as an introductory course, it'll hardly be the case. Okay. Usually we'll have, mostly, only one relationship. In some cases we have multiple. And in some cases, you may have to have a constraint, a minimum constraint, uh, not many, not one. So if you have a specific numeric constraint, you put that number on top of the or next to the dashed line. Okay. So what we are saying is a course must have more than one professor qualified to teach it, but the minimum number required is two. Or another way to say is uh, at least two professors must be qualified to teach the course. Okay? Or each professor must be qualified to teach at least one course. So when you know the lowest number or the maximum number, the minimum or maximum constraint, write that number on top of or bottom of that relationship. So this for now, let's just skip. Sample ER. So now you should be able to read all this, like what these things mean. For instance, let's see. So item is used in product, or item is used in many products and it's a must. So item must be used in many products, right? Or at least one, like it's mandatory for an item to be used in a product, and so on. So then there is something called a weak entity. So weak entity is something that cannot exist on its own. Okay, it needs other entities to exist before it can exist. For instance, dependents cannot exist on their own. If the record in the main database is removed, the dependent should be removed as well. Okay, like if an employee is removed from the university, their dependents records should be removed as well. So a dependent becomes a weak entity. So dependents can have their own attributes. So there are different entities, but they cannot exist on their own unless a strong entity exists. Okay? Defined as something like this. So a double dashed box is a weak entity. And the relationships between a strong entity and a weak entity is defined as a doubled line, or a double line relationship is the identifying relationship between a strong and a weak entity. Okay. For the identifiers, the weak entity does not have a unique identifier, only a partial identifier, meaning that those entities are identified by this main identifier, and based on this you have a partial identifier. So employee John has two kids, Mary and Jane. So Mary and Jane are defined by their own names or maybe their social securities, but they are dependent on this, so their identifier will have a double dashed line under the identifier, but the employee will have a single line. Okay. Then associative entity is usually you can think it as, like the name states, it's an association between entities. So what's the difference between a relationship and an associative entity then? So the main thing is entities have attributes, relationships link those entities together. But if a relationship is many to many, has other unique identifiers, a unique identifier and other attributes, usually in three-way relationships, then instead of having a three-way relationship, make it an associative entity, provided it has a key of itself, unique identifier, and other attributes. So this is a major thing. It needs to have a unique identifier and other attributes. If that kind of relationship exists, usually between three-way relationships or in three-way, then make it an associative entity. Okay. Associative entities, unlike weak entities, could have meaning independent of other entities, meaning they can exist on their own. They do have unique identifiers and can have other attributes. Example. Let's read this. What does it say? So it says an employee or multiple employees can complete multiple courses, and each course can have a date completed. Okay. So either you can form it like this, or if this date completed has multiple attributes, something like this. So it has a date completed, it has its own certificate number. So each certificate has or can be identified by this identifier, and then there is an additional attribute. Then instead of making it a relationship with two attributes, make it an associative entity. Okay. Now notice the difference in the notations. Now instead of the notation of the multiple going in the like reading from employee to course, this crow's foot is going in course, and reading the other way, course to employee, this B crow's foot is going inside employee. Instead of these going inside these crow's feet go inside the associative entity. So if you look at this, so B is now going inside this instead of going in the employee, and A, instead of going in course, is now going in that associative entity. And then based on whatever logic there is, the other side you can decide based on the problem at hand. Okay. So many-to-many cardinality is replaced by two one-to-many relationships. Okay. So here um, it's drawn as an associative entity. It can be this, or um, it can be an attribute, relationship with attributes. It's your own call. Which is better? There is no science to it. Do you have to have associative entities instead of relationships? No, because in the end, when we model our database, um, when we transfer it to MySQL, both things transfer the same, okay, or transfer similarly. The only thing is which looks graphically better, or which can be understandably, or which can be understood better, okay. So it's a judgment call. So let's look at like a few examples. So what does this figure, if you try to read this ER model, so what does it represent? So again, reading from left to right, so beers, which have their own attributes. A beer has a name, it has a manufacturer. So beers are manufactured by manufacturers, and what's the constraint? A beer must be manufactured by one manufacturer. Must be only one manufacturer, right? So think of Anheuser-Busch manufactures. What's that? That's a Coors Light or whatever. Reading the other way from manufacturers. So a manufacturer manufactures many beers, but it does not have to manufacture any beer. So manufacturer can exist on its own, but it's optional that it's making beers. It may be manufacturing other types of beverages. Okay, so manufacturer manufactures many beers, but it's optional. Okay, reading right to left. What's the problem in this design? So the design, I say, is bad. Why is the design bad? If you think of it, this is a bad design. Why is that? So if you look, what are we storing in each table or in each entity? So here, manufacturer has a name, an address. Here, a beer has a name and a manufacturer. So manufacturer name is being repeated in the design, right? Can we rectify this? What if we do this? So beers have names, they have manufacturers, and each manufacturer has an address. Why is this design bad? Right, so if you think of multiple beers, beer 1, 2, 3, 4, each having the same manufacturer. So what are you storing with each of those records? So this design is essentially repeating the manufacturer's address once for each of those beers, right? If we need to update the records and so on, so instead of doing it in one place, you'll have to update all those 4, 5, 6,000 million records, right? That's why this design is bad. This, on the other hand, is an example of a good design. The same thing as we saw in the bad design. So instead of the manufacturer name, just don't do that. Don't store that. That thing can be accessed from this table. The relationships stay the same, right? So this design gives the address of each manufacturer exactly once. So if you need to update, delete, add new, it has to be done only in one place. No need for repetition. So then the next thing, like we talked earlier, when should we have entity sets? When should we have attributes? So entity set should satisfy at least one of these conditions. So it is more than the name of something. It has at least one non-key attribute. So this is that relationship attribute versus associative entity, right? Or it is the many in many to one or many to many relationship. So then make it an entity instead of just keeping as an attribute. So what are we storing here? Read this, right? What's it saying? So manufacturer has a name, Anheuser-Busch, let's say, manufactures many beers, but it's optional. And look at the constraints, look at the number of attributes, and let's look at our rules back again. So rule says it is more than the name of something, meaning it has at least one non-key attribute. Does this one have at least one more attribute? No, it only has a key attribute called name. What's the other condition? It is the many in many to one or many to many relationship. It's the many side. Is it? No, it's the one side, right? There is no crow's feet here. So it should not be an entity set. So manufacturers should not be an entity set. Why? Because the condition of an entity set versus making it an attribute, these both conditions are not satisfied. Okay? Or either of these is not satisfied. So instead of making this, we draw this thing. So there is no need to make that manufacturer an entity set because we record nothing about manufacturers beside their name. If there was an address, yes, you could say that we need to store it something else because there's another attribute. But in this case, if you're only storing the manufacturer's name, this is a good design. Okay. Here we have that address, the non-key attribute. So this is a good design. Okay. So this side deserves to be an entity because it has non-key attribute. This side deserves because it is the many side. Okay. It's in the many side of a many to one relationship. Then another thing you guys need to be wary of in designing databases is do not add unnecessary relationships. Okay. It may be possible to deduce a relationship from another relationship. So in this one, do we need the relationship instruct? So students take courses, students are instructed by professors, professors teach course. Do we need this? No, because we don't need this instruct relationship because we can deduce that students take courses that are taught by these professors. So student X takes databases taught by Professor Smith. Do we need to say that student X is taught by Professor Smith or instructed by? No, this relationship is redundant. It's not needed because you can extract that information through this way, take and teach. Okay. However, in some cases you may need. So here I'm saying take and teach are both needed. Do we need the relationship take between these two and then teach between these two? Yes, because student X takes databases. That's one relationship. Professor Smith teaches databases. So student X takes databases taught by Professor Smith. So that is now evaluate, is there a new relationship? Do we need that? Or is this storing something that this relationship is not storing? So do we need evaluate with take and teach? I would say yes. Why? You can pause the video and think, but the answer is student X takes databases taught by Professor Smith. That does not mean that student X has evaluated databases taught by Professor Smith. So you guys, when you do evaluations, in some classes you might have skipped or you have to skip. Otherwise you do evaluate everybody, right? So the evaluation relationship is different from this take and teach or instruct relationship. So that's why in this case this is needed. Okay. So then this slide tells you when you need to convert an entity set and attribute, when is one needed. So read through that. We've already discussed. The other thing is don't overuse weak entity sets. You might think that anything is weak, like it needs to be supported by other entities. Don't do that. So be wary of using weak entity sets. Then binary versus three-way or non-binary relationships. If you have to have like a three-way relationship, it's maybe better to redesign it and think of it as a two-way relationship. If you cannot, just make a three-way relationship at first and then try to reduce it in this manner. So the theory is up here, but in essence what you're going to do is that if you have a three-way relationship, which is this R between these three entities, instead of that three-way relationship, you make three other relationships connected with a entity in between. Okay. Instead of A, B, C all connected to through R, you have a relationship between A and entity E called RA, relationship of A with this entity, and so on. But again, these are for our introductory class, we may not need it. And the final thing is make sure you understand this slide, like you understand what's happening here in this figure. Like these business rules you can deduce from this figure. Okay, and that is all for today's class.